All right, we are live now. Okay, I think folks are joining us shortly. We'll wait for one more minute. By 4:02, we'll get started. All right. Okay, I hope my audio is audible. Just let me know if there's any problem in the chat. All right. I think we are good to start now. I'll be starting the session right now. If there's anybody joining, yeah, maybe they'll join. Just let me know if my audio is clear in the chat. Yeah, cool. All right. So before getting started, I would like to ask you a few questions. Maybe you can just give me your answers in the chat. Like, you guys ever wonder like how these fitness gadgets and this fitness wearable devices that measures your heart rate and then number of steps that you have taken and gives you the certain exercise plans tailored to you. So that's what we're going to see today, how this Internet of Things is changing our lives through this 1 hour session on Know Your Internet of Things by Kadiyam Kishore, and that's me. So I would like to introduce myself before explaining you what this IoT and new terminologies that you guys are hearing these days. So I'm Kishore Kadiyam. Currently, I'm working as an research and development in the field of industrial IoT at Siemens Advanta. I have 5+ years of experience in IoT, and I worked with Robert Bosch and currently working with Siemens. I have built couple of enterprise and industrial based IoT applications in that domain. All right, so starting in the first one, this is our agenda for the day. In the introduction, we'll be taking you through a couple of examples, like what is IoT and what kind of applications do we have in the market right now, so on and so forth. And also, I'll explain you what are the features to consider one system as an IoT system or maybe an IoT application. And then I'll walk you through a couple of architectures that we have in the market, which are quite adaptable in any kind of systems design that you are going to do in future. And then I'll explain you a couple of gists on IoT protocols that we have, that we follow every day to day without knowing each other. And then I'll explain you the scope of IoT, like where exactly we can apply IoT in day to day life. And also I'll tell you what is the business value that we have for IoT in the market at the moment. Maybe in this business value slide, probably I would explain you what kind of careers that you can pursue, maybe like in which domain you have this niche in, and so on and so forth. Yeah, maybe we'll walk you through. We'll have, if you have any questions, keep it posted in the chat. Maybe in the last 10 minutes I'll take your questions. Great. Thank you, Riaz. Yeah. Thanks for confirming my audio is clear. Thank you, everybody. So let's get started without any further ado. So, what is IoT? So, you guys might be hearing this word everyone, and then your teachers might be telling, okay, IoT have very good scope in the market. People are saying this is an IoT project. It's it's a buzzword these days, right? So, what is IoT? At least, I mean, if you have any idea or something, just let me know in the chat. But since we have in the interest of time, I'll just walk you through. In the nutshell, the Internet of Things is a concept. Okay, it's not a technology, or it's not a platform, or it's not something that you can learn overnight. So it's a concept of connecting any device to the internet so that you can exchange data and you can use that data to make beautiful insights, or maybe you can do some monitoring, or maybe you can do the anomalies detection, like a lot of other things. So technically, in a layman language, if you are newbie to a IoT, I would say it's a giant network of connected things and also sometimes people, all of which to collect and share the data. Okay, and also this information is regarding, it can be regarding a person, it can be regarding the environment, it can be regarding anything. So technically, the exchange of data by connecting over internet and making beautiful insights out of it is IoT for me, at least for anybody, right? You can see, maybe for example, I would say, if you take the example of a self-driving car, that's a kind of IoT that we are being doing there, right? And also we have this microwave ovens. If they get connected to internet, and if you're able to see what's happening inside, that's also kind of IoT project. And to take another example, we have washing machines these days, like where you can monitor your clothes that are being washed by your machine in real time. Yeah, or maybe you can set the settings of your washing machine over internet. All right, so this kind of projects are technically IoT. So I would say IoT is never a technology, it's a concept. All right, the goal of IoT is to form an ecosystem of connected devices. Okay, that's the main intent of IoT. Okay, or maybe to create an ecosystems from things to things. As you can see in this picture, there are many places that we have this IoT as a concept exist. Maybe in the airports, maybe in the factories, maybe you can probably monitor a lot of critical assets in the factories, maybe in the manufacturing plants. Okay, I'll walk you through that shortly, maybe in the slides of applications. All right, so yeah, coming to the next one. Why do we need IoT? Okay, I've been blabbering from last couple of 5 minutes, I guess. Why do we need IoT? Okay, we have this question running in our mind. So these are the 5 points I would say necessarily to be considered when you're working on a IoT project. The first one is more data means better decisions. All right, so that means you have technically, I mean, I would like to give you one example. Maybe I'll take my whiteboard. Okay, so if I say all fruits that are red in color are apples. Okay, and then I'll say all fruits that are small, okay, in size are grapes. Okay, so if I have only these two pieces of information, if I really give you an apple, you can simply classify it as an apple based on the color or maybe the size, right? What if I gave you a strawberry which is smaller in size? Okay, that is already in red, that is smaller as well. So if you have more data, maybe in the third point, if you say if I have small fruit in red is strawberry, that means you have extra data, right? So that means you will have better decisions to make. So that in the similar fashion, if you have more data, you can make better decisions. All right, and then second point, ability to track and monitor things. Okay, maybe if you can consider one example as you guys might be ordering Amazon packages and all, right? So you want to track your packages, where and all your package I mean your package has been delivered, where exactly it is at the moment. So there is something happening behind the cloth, right? That means the parcel that is being sent to you is being tracked somewhere. So you'll still have the transparency, you can monitor your things. That's still an IoT network I mean, doing something in the background, right? And then the third point, lightens the workload with automation. Yeah, maybe like let's consider the other example of you guys might be hearing this, right? Like delivering the packages using drones by Amazon, right? So that's also a kind of IoT, where you have to have your live tracking of your drone needed, where exactly the package is being delivered, and that's getting automated. There is no human intervention needed, right? Your drones are directly delivering it to your doorstep. There is a reduction of manpower, right? That is also one of the feature that you need to consider. And then the third point, increases efficiency and also saves money for the business. and also it also betters the quality of life. As you can see, I mean, as mentioned earlier, we have an example of washing machine, right? So where you can monitor your washing cycles, right? It increases your quality of life. You don't have to go and check whether your washing machine is on, whether your washing machine is still running or not. You don't have to do that. It increases your quality of life, right? So these are the technical, this is why we need IoT. These are the points I consider that a system needs to qualify as an IoT system. All right. What are the features that I would say as an IoT systems? Okay, these are the must-have features, and as a technical or as a physical need, what are the features that you consider as an IoT system? I would say these are the four important features of IoT system. One is collect, another one is connect, other one is analyze, another one is integrate. So I would like to make use of my whiteboard again to explain you guys in detail what is collect, connect, and everything. So first one is collect. So as I mentioned, IoT is nothing but connecting your devices and collecting the data. So the first step is nothing but you collect the data from, it can be sensors, it can be human entered, it can be anything. So you the first point must be it should have an entry point where your data comes in. That means you're collecting the data. And then the second one that goes is connect. So you need your devices or whatever is the endpoint, should whatever the data is collected, that needs to be sent over internet to another system, right? There you need some protocols maybe, which I'll be explaining you shortly, right? And then the other feature I would say, that is analyze. So whatever the data that you have, you need to analyze the data. What exactly is this data? Why do I need it? Should I process it or not? Okay, whatever is processed, I have to store it somewhere, right? So that analysis have to be done somewhere. So that is another part, another feature. Okay, and then the final feature I would say would be integrate, right? It's integrate. So integrate is nothing but, so you have your data. What should I do now? What should I do with my data? I have to draw some insights. I have to bring some business value to it, right? I have to do some monitoring over the data. I have to provide some beautiful insights to the users, right? So that part is comes under the, I mean, that part comes under the integrate as a feature. So if you combine all of this, okay, we'll technically form an IoT system. I'll give you another example, maybe in the context of these features. So the first part will be, I have technically, I have some sensors, okay, some sensors that are measuring my home temperature, okay, some home temperature. So this data, whatever is being collected, okay, needs to be sent to my internet, maybe the some cloud system that we have, okay. So this data transfer will happen, okay, to another system in the cloud, maybe, okay, some cloud services, okay. So this cloud services will store my data, okay, and also I need to do some analysis, right? So this data will be sent to my analysis system. So in this analysis system, I'll technically make some decisions based on my I mean, I'll make some decisions. I'll analyze, okay, is the temperature very high, is the temperature is very low, okay. So based these decisions will be made in this analyze phase, okay. And then whatever the decision is made, okay, the temperature is very high, I need to increase my uh, maybe the temperature points in my AC, okay. So those decisions are, maybe those signals will be sent to my AC, all right. So you can see this is technically, here there is no intervention of a human. So your temperature sensor is measuring the home temperature, and then the data is being sent over internet to some cloud services where some analysis is being done, making some decisions, and based on that you have your AC being turned on and off, okay. And then we can take one more example, maybe, okay. You guys are coming from the offices, maybe from the college, okay. You want your AC to be turned on, maybe this is a feature which is already available in the market, okay. How is it actually happening? So when you guys are coming from your college, there is something called geolocations. maybe you can say you are entering this geolocation. There will be some trigger happening, right? There will be some trigger happening. uh, so trigger based on your geolocation. Okay, so trigger based on these geolocations. So this trigger combined with this sensor data. Okay, what if the temperature is already very cool? You don't have to turn on your AC, right? So it will check whether the temperature is good or not. Those decisions will be made in this particular part, and then the AC will be turned on. You can still integrate this particular service to this. Okay, so the more data you have, you can make better decisions, as I have told earlier. It is still qualifying, and then doing this, there is no intervention of your own self, right? So it's actually bettering out the I mean, it's actually giving the better quality of life for you, right? That's what the IoT is doing to you. All right, I hope I'm clear with this collect, connect, analyze, and integrate part. If you have any doubts, maybe you can post it in the chat. I'll clarify it in the end of this session. All right, so yeah, we have seen how these systems are designed, like how a IoT system works, how you can design an IoT system. But there should be some architecture being defined in the background, right? So what is that? Yeah, exactly. There is no single architecture available to say that this is an IoT system which is universally agreed. No, nobody said that. I just made it out of nowhere. Exactly. So but what exactly architecture? Which architecture do you use in your day-to-day projects? If somebody comes and asks me, Kishore, you're working as an IoT engineer, so what architecture do you follow? So I would say I was using this main features: collect, connect, analyze, and integrate. But there is no such architecture available. So based on my distributed systems knowledge and then required requirements that comes to our bucket, we make our decisions accordingly. So we use something called layered architectures. Okay, so those layered architectures, again, I'll just open my a whiteboard. Probably I'll create one more whiteboard. So I'll explain those layered architectures. Just a second. Yeah, so these are nothing but these are again inclined towards our first concept, the features of IoT. Okay, this is one three-layer architecture. Okay, so the first one is perception layer. The perception layer is something where your user interacts. Okay, this is where your user interacts. Okay, it can be sensor or it can be something like a mobile device, right? So whatever data that we collect here from the perception layer, it goes to your network layer. Okay, so over any kind of protocol, it can be HTTP protocol, it can be Bluetooth, it can be anything. Okay, there are many other protocols available. I'll be walking you shortly. Okay, so this data is being sent from our sensors to our Bluetooth or maybe the gateways or maybe something else. Okay, this gateways will communicate to application layer. Okay, where you have your cloud servers available, where your data will be transformed and anything. Okay, so this is a very simple architecture, I would say. This three-layer architecture. If I keep it in line here in the users layer, you will have your collect. Okay, and then in this network layer, you have your connect feature, and then in the application layer, you have both analyze and integrate. Okay, so everything is actually in line with in line with this particular features that we have discussed earlier, right? So yeah, but here, why do we have analyze and integrate all together? That's what the requirement wanted. It doesn't want any beautiful UI to show, or maybe beautiful dashboards to show. Maybe, yeah, that's how the requirement. That's when we follow this three-layer architecture. Okay, so how do we do that? Maybe something else comes up in future. Maybe they say, okay, yeah, I want to track the data that is being sensed in the perception layer. That's when you will have this another five layer architecture. Okay, again, perception layer, where you have your collect part. Okay, this is where you will have your collect. You collect the data. Okay, and then in transport layer, again, this also connect. Maybe this together will I mean, sorry, yeah, this part will say connect, Okay, and then analyze part will lie here. Okay, and then we have integrate part, which is bringing up. So here, if we take the example of our Fitbit, okay, which is tracking your heart monitoring system, okay. So if you want to bring some beautiful value for the data that is being tracked out of you, as you can see, first it collects the data inside the perception layer, which you are wearing into your wrist, right? And then the data that is being collected will be sent to your gateways, routers, and Bluetooth. Here, the gateway would be your mobile phone, right? So that the data whatever is being collected will be sent to your mobile, and that mobile is capable enough to communicate to any cloud servers, right? So it will send the data to this analyze part, okay, where it will store the data and then do some machine learning algorithms on top of it, and then bring out whether the user, or maybe the whether the data whom it belongs to has a risk of getting an heart attack, right? So that kind of processing will be done, and again you want to bring that business value out of it, right? That's what Apple is doing all these days. They want to show the user whether he has the heart attack or not, okay. And then that analyze part is coming to the integrate, where you'll have that insight. Okay, yes, you are a healthy human being, or maybe it will say you have a risk of getting heart attack, get a heart checkup done, okay. So that kind of insight can be given. That's a file layered architecture, okay. They still can be refined, okay. You can add even more layers here, okay. But why do we need that? Okay, here maybe in this example I just quoted, where you have your personal data being tracked. It's saying maybe my data, Kishore's heartbeat data, okay, which you don't want to share it with others, okay. You need some security layer also to be involved, right? So in such cases you can probably use the 7 architecture layer. In this you have security layer, extra security layer being added, and also sometimes edge layer, okay. So I'll talk about this edge layer shortly, okay. But before that, I mean, why do we need seven IoT architecture layer? Just to bring a more refinement, okay, to your architecture. That's when you bring up your 7 IoT architecture layer, okay. So this is all about the architectures. So you have different layers, and again I'll come to this layered architecture maybe in the last of my session to explain you where exactly you put yourself in this layers, okay. It's not one person handles all the layers, okay. It need a lot of people's effort and a lot of people's expertise to make this IoT thing happen, all right. So I'll tell you where exactly which engineer is needed, why he is needed there, and all in the last part of this session. All right. So yeah, this is the 7 layer IoT architecture layer, okay. And then these are the some components which you might be hearing from so long, okay. What exactly is cloud computing, edge computing, conditional monitoring? So these are some of the jargons that you might encounter while working with IoT projects, okay. So the first one will be cloud computing. Even I was also explaining you guys, there are cloud servers inside here, right? As you can see here, there are some cloud servers which are being used. So what are these cloud services doing? So so earlier what used to happen is you used to run your servers in your local machines and then expose it using DNS. So that's a kind of a maintenance hectic. So which is why there are many market players which are providing you these virtual servers, okay, over a web interface, where you can configure your services and servers in that and then make use of it, okay. You will get much more insights when you start working on these different cloud servers, I mean cloud services available in the market, okay. That's what the cloud computing is like, wherein you have, I mean, you process your data, or maybe you use a virtually hosted servers in the data centers from a remote location, and then bring up your services inside that. That's when the cloud computing comes out, okay. And then the edge computing, yes, as I said, there is something called edge layer here. So in this example, if I say so maybe here, if I send my heartbeat data to a server and then process the data and then get back this insight to your mobile saying, okay, you are suffering a heart attack, there is a lot of latency involved, right? So it needs to transfer between different layers, okay, sending the heartbeat data from sensors to mobile, and then mobile to your cloud, and then cloud to the business model. This is a lot of latency. So what if all of this processing, all of this data processing is being done only on the device itself? That's when you will have this something new concept called edge computing. So wherein you can deploy your AI models, you can deploy any anomaly detection models, maybe I mean which involves a lot of computancy. Okay, in order to eliminate this latency, we brought up a new concept called edge computing. Okay, edge means your device, the edge device. Okay, so that device should be capable enough to run this edge modules and then do this all processing into the device itself, so that the latency is reduced. So whenever you encounter a heart attack, you can directly get that insight to your mobile saying, okay, you are facing some heart attack, please call 911, whatever. All right, so this is how the edge computing is changing our lives in critical decision based systems. Okay, and then the conditional monitoring. So conditional monitoring is pretty much similar as checking the temperature. You are technically monitoring something, some telemetry data. Okay, some sensor values, maybe temperature, it can be humidity, it can be vibration data, it can be anything. Okay, you must be monitoring something. That's when the conditional monitoring comes into the play. And IIoT, what you've been hearing this IoT from the starting of this webinar, right? So what is IIoT? It's called industrial IoT. Okay, if you apply your industry, I mean IoT concepts in terms of industries, so that's called IIoT. It's pretty much plain. Okay, it's pretty much plain vanilla. All right, so but if you guys are aware of industry 4.0, which is the current revolution happening, I think industry 5.0 is also coming into the market. So that's where the IoT concept was in a huge hype. Okay, and then what is IoE? IoE is nothing but Internet of Everything. Okay, it includes people also. So far I was explaining you wearable as an example, right? Some heartbeat tracking wearable as an example. That also comes under the hood of IoT, IoE, right? IoT also comes under the hood of IoE. It's nothing but where anything and everything can connect to internet. It also involves people, it also involves things, it also involves virtual devices, anything. Okay, that's what IoE is. These are some should know concepts. You being students of this current generation, you should be knowing like this kind of small terminologies which you'll be hearing every when and then. These become like a huge jargons these days. Okay, yeah. So what are these IoT protocols? So I was telling, okay, there was this sensor which is communicating to the internet, and how this communication is happening. Okay, there are a lot of protocols which we have in the market. Okay, the first, so these are the list of protocols. I mean, some top 10, maybe my top picks, I would say. There are a lot of other protocols also available, but these are the most used protocols. One is AMQP, Advanced Query Protocol, and MQTT, message queue telemetry transport protocol. BLE, Bluetooth. This is like, I guess you guys might know what is BLE. Like it is very much famous even in your mobile devices, and lot of other beacons, BLE beacons available. And Wi-Fi, yeah, you guys might be using Wi-Fi. Yes, Wi-Fi is helpful for creating mesh technologies. There are a lot of other protocols also available in the market, but most of the projects will use MQTT, BLE, because they have wide open source and good community support also. I don't say the other protocols won't be used; they also will be used, but they're very much picky based on the use case that you guys are working on. Okay. So yeah, scope of IoT. So we have been discussing this IoT, how these systems communicate, how different parts of IoT communicate, etc., etc. But where exactly can we apply this IoT? As I say, everywhere. The first example would be agriculture, where you can monitor your soil and also your environment. Based on that, you can take the decision on which crop you want to plant. Okay, maybe if you are doing some indoor planting, okay, maybe IoT can helps you in monitoring and managing of microclimate conditions. Okay, maybe if you have a sprinkler system, okay, if you have very dry state, probably you can start your sprinkler system automatically. It eases out your life, right? So agriculture is also one of the place where you can apply IoT. And coming to this healthcare, excuse me, yeah, coming to this healthcare, where if a person is critical and the doctor wants to leave for some other patient, he still can monitor in his mobile, maybe in his watch, right? He can still monitor a patient's vital even from his home. Okay, if there's any decision need to be made out of the data, he still can communicate for somebody who is actually taking care of that patient, right? So this can even healthcare is one of the beautiful example for IoT applications. And industries, yeah, this is industry 4.0 and IIoT concept that we're talking about, where you can install different sensors on uh, machines, different machinery parts, a lot of other industry components, and then monitor them. If there is any anomaly detected, maybe you can put a machine learning model to detect future failures. Okay, saying okay, this machine tends to get failed in future, probably it needs a maintenance. You can do a predictive maintenance also. So that kind of applications are applied in industries also. And coming to the transportation, yeah, I have quoted one example where you can see your shipment being tracked, right? It's under the hood of IoE. And then one beautiful example which you guys might be seeing this in the different forms also, like where there are some shipments which are supposed to be shipped in their typical temperature, maybe an ice cream. Okay, an ice cream should be tracked, right? So you cannot give a juiced out ice cream or then saggy ice cream to a vendor. He'll not buy it. He needs that ice cream has to be in a proper condition. So maybe what if your container got failed? Maybe what if your container which has that temperature maintenance system got failed? You can still detect that in the transportation field. Yeah, IoT will help you high time in doing that monitoring. Okay, and not only these four examples I have quoted, there are many, I would say, many lot of, I would say. So one is consumer use. I said for consumer consumer uses, like maybe you can you can put some sensors on top of your inverter batteries and then see the quantity of what do you say, electrolyte, maybe whatever the charge is left over the internet. Okay, and then you can use it in the insurance domain also. Maybe it's based on the patient's vitals, maybe based on his fitness tracking, he can provide some tailored fit insurance plans. Okay, and also in the energy. So energy is also one of the beautiful concept where blockchain is also being integrated. Let's not talk about blockchain now, it's another huge concept. Also smart cities, home appliances, traffic monitoring, and many other applications. I mean, name it, anything you can. If it has capability of connecting to internet and sense something, that's good enough to qualify for an IoT project, maybe IoT application. Okay, so yeah, maybe in this course of my tenure in like last 5 years, so I have worked in couple of hackathons also, which got us first place in Microsoft Hackathon 2020. So this is a small demo on how we made an existing problem as one of our application, and we made a solution for that. Maybe I'll just quickly just show you some 2 minutes video. You can just have a look of it. Just let me know if you guys can see my
Kadiyam
screen.
Droplets takes advantage of some of the newest Intel and AMD CPUs available.
MotoGP rider Maverick Vinales forced to leap from bike at over 200 km per hour after brakes catch fire. Rider escapes injury after motorbike catches fire during race. World Superbike rider Javier Forres engulfed in flames. South American MotoGP race came to a fiery conclusion when Yoni Hernandez's Ducati burst into flames. Hello, we are a part of Team Reboot Rebels.
As seen in the newspaper articles before, the problem is that the components of the sports vehicles may fail at any time, causing fatal injuries to the drivers.
Is there a solution to this?
Yes, I have an idea.
Presenting to you Overwatch. Firstly, by logging in with your organization's credentials, you'll be able to see the homepage of our website. On the right is a digital twin of a vehicle. For demo, we have chosen to implement a 3D model of a bike, through which you can adjust the position to see different components of the vehicle. Going ahead, we're looking forward to implement similar applications for different vehicles, especially for military vehicles. And on the left-hand side of this page are the parameters which show real-time digital values from the sensors which are connected to the different components of the bike. Clicking on Analyze button, we'll be taken to a page where we can visualize the real-time digital values of every parameter in a graphical form. Here we used MS Azure's IoT Hub to stream the data on custom portal. We have so far worked with a few parameters like tire pressure of both the tires, emission level, engine heat, suspension, battery level, fuel level, and speed. With time, more parameters can be added to this same application. Next, we have anomaly detection. From Microsoft Azure's Cognitive Services, we have chosen Anomaly Service API to detect abnormalities of the vehicles in real time. We are using the built-in function called Anomaly Detection Spike and Dip that takes a sliding window of data and examines it for anomalies. As the flow of data continues, the algorithm establishes a normal range of values and then compares new values against those normals. Now Srihari will be explaining.
Yeah, I hope you guys liked this video. So it's technically very much simple. Okay, so there is a problem statement like wherein the MotoGP bikes they catch fire on the go, right? So without any intimation, I mean without any intimation, like the user, the bike rider may get catch, they catch fire, right? So why is this happens? Okay, why does this happen? So the first thing will be there must be some failure, there must be some tire pressure increasing, so which are not seen through our naked eye, but they can be sensed with the sensors, right? So what we try to do is we try to put sensors on the bike where you can monitor a couple of things like engine heat, tire pressure, and then there are many other components that we have measured in, as you can see in this video. So using that sensor values, whatever is measured, we have sent this data to the Azure IoT cloud and then make some insights out of it to find the anomalies. Okay, we have developed one anomaly detection system based out of the sensor values. If that spike in some value comes up, it says it's an anomaly, so the rider has to change his bike. Okay, maybe that can help to save lives, right? So in this fashion we try to implement IoT as a concept in day-to-day examples. Okay, yeah, next coming to the business value. Okay, so there must be some business value. That is the reason every company is behind this IoT, right? So what is the business value? So in 2021 it was estimated that it has 300.3 billion USD market at the moment, right? So it's growing tremendously. It has a lot of ample amount of jobs. Like by 2026 it was expected to be 2x growth, like $650 billion USDs. I mean, imagine the number, how big it is. Okay, it has an annual CAGR of 16.7. So by every year it's going at more than 15%, right? So imagine by 2030 how big the market for IoT would be. Okay, because the main reason behind this growth would be like it has IoT is not just a technology, right? It's a concept. So in order to bring this concept live, there are a lot of other domains also need to pitch in. Okay, it's not only one domain comprises of IoT saying okay we do this. No, it requires a lot of other people's expertise, lot of other domains expertise also involved. Okay, which is why it brings me down to the other topic. Okay, where exactly you can see yourself in this IoT as a IoT as a concept. Okay, yeah. So coming to this future career options, maybe in the business layer you can see yourself like a manager. Okay, we need managers to manage the IoT projects, right? IoT teams. Okay, and then the application layer where you have cloud servers and cloud services. Maybe I mean you have to be a full stack developer to make a backend system for your IoT system. Okay, maybe you need, as you can see in our project, we have a beautiful UI. So where we have some full stack developers efforts went into. Okay, and also you can be a cloud engineer to manage these cloud services where exactly the data comes and sits into your system, and then you have to store your data, right? Where your expertise of database comes into play. So you can be a database admin also. Okay, who can still contribute into the IoT project by storing the data of sensors and everything which are being sensed. And also transport layers wherein you can design your Bluetooth systems. Okay, maybe the gateways which takes the data from sensors. Okay, maybe which can communicate to the internet. That technical embedded devices, I would say. So those devices who can be one profile where you can see yourself. And also sensors, maybe you can design a sensor, not only the temperature sensors, maybe you can integrate all of them in a single sensor and then give it across. Okay, so there also you can see yourself. Okay, edge layer. So edge is another technology altogether itself. Maybe you can contribute in the being an edge, I mean IoT edge engineer also. Security layer, this is a very vast concept. Okay, security not only applies to IoT, every system that you use, okay, requires a security layer, or else you have intruders with who are like fishing for the data. Okay, so even security engineers are needed to make an IoT system. So you take anything like you can pick any of your niche, okay, any of your interest, and then start working towards it. Okay, it's not necessary you know only one. You can know anything. You can work on any of the given layers. Okay, you can pick any of the profile and start working on it. Okay, if you take my example, I started as an application developer, and then I started being a transport layer guy, where I'm currently working and writing code for IoT gateways. Okay, I worked for processing layer as well, where I have designed couple of IoT systems to store the data of different sensors. Okay, yeah, you can see yourself in any of these layers. This is the reason, as you can see, there are around 7 layers. If you take two profiles per layer, 7 into 2, there are around 14 profiles for IoT, which is why we have a huge market for IoT. You can place yourself. And one more thing, probably you guys might be a couple of you guys are mechanical. Maybe you can say, dude, where can we work? We are not we are mechanical guys, we don't know this coding, etc. No, it's not necessary, right? Maybe if you want to, maybe the decisions are made. Okay, maybe in the industries. Okay, the one insight was made. Okay, some maintenance is needed on top of a machine. Okay, that's when the mechanical engineers can come into the play, right? And then probably you can actuate the process. Okay, maybe for actuation you might need to code a PLC, or maybe some HMI devices, right? So yeah, we need everybody's expertise to make this IoT system happen. Okay, it's not one person doing IoT. It's a collective effort needed to make an IoT system happen. Okay, and yeah, so that's it for the today's session. I hope you guys liked it. If I have eaten up your time a lot, excuse me for that. And yes, please do subscribe to our channel Techvanto Academy, and also you will be getting certificates for attending this live session. Okay, the links will be shared by our Techvanto Academy team members. They'll be giving you some links. You just need to fill out your required concerns and all. Maybe you will required information also, so that you will get your certificate. And then you'll also get a feedback form, where you can enter your feedback, which helps us high time in tuning ourselves to. And if you want any future IoT courses, where you want to learn how sensors data will be collected and then send this data to the cloud, how the data gets processed, and then this processed data will be used to make insights, how does this happen. If you want to have some boot camps, if you want to have some live sessions, or if you want to have some live courses on IoT, do let us know in the feedback section. You have your URL in the comment section. Okay, chat window, just post me if you have any questions. Maybe we still have 15 more minutes. I'll answer your questions. I think I have covered most of the concepts. I think you guys know what your Internet of Things is, where you belong to also in this spectrum of different profiles. And then yeah, there is pretty much to learn. I would say I don't say if you attend this session you will know everything about Internet of Things. No, even I myself don't know much about Internet of Things, right? So yeah, whatever the knowledge I have, I try to share it across to you guys. If you have any questions, if you don't understand anything, probably let me know. I'll just reiterate over through it. Okay, any questions, guys? Do let us know if you need any boot camps on IoT systems, and any courses if you want to have in future, maybe in the upcoming days. If you want to attend any of our sessions. Okay, and also do subscribe on YouTube for our channel Techvanto Academy. And also we are planning to start a 30 day session on IoT. Okay, we'll have a cool live projects working on that. Okay, we'll definitely have our hands on and make our hands dirty for sure. Okay, if you have any questions, do let me know. If no, I think you guys can fill out your details in the both the forms shared. Maybe one is the feedback form, another one is your certificates form. Do fill out, you'll get a free certificate for attending this live session. And also don't forget and smash the like button for Techvanto Academy. And also bring up your friends for the future upcoming events. Also, do call them. Just do a mouth spread technically. Okay, grow and let grow. Okay, the feedback or the certificate verification link will be activated in 5 minutes. Just some glitch maybe. Yeah, it'll be active in 5 more minutes. Maybe after 4:50 you can start filling out. Yeah, Abhishek Kumar, thank you. Thanks for attending the session. I don't know who else are attending this session, but yeah, thanks for attending this session. Just do let us know your feedback. It will be helping us in bringing up some beautiful courses for you in future. Okay, do subscribe to our channel, and also yes, you can watch this video across again if you have any doubts maybe. Okay, do reach out to me if you need some career support or maybe some concept level support on IoT on LinkedIn. Maybe you can just type my name Kadiyam Kishore and you will find me on LinkedIn. Okay, if you have any questions, just post it over chat. I think there are no questions being posted. I think, yeah, I hope you guys are clear about what IoT is, how things work inside IoT systems, and what exactly IoT as a buzzword mean. I hope I have given enough information for you guys to start upon. Anyways, all the best and keep rocking. Just post us your queries and feedback in the given links. Thank you guys. Thank you so much.